Number 51, they want me to do the inverse function. So inverse for 51, I like these. I'm going to rewrite it as y equals the square root of 10 minus 3x. Flip-flop the x and y, so it's going to give me a new equation of x equals the square root of 10 minus 3x. Inverse operation, square both out 3y. I'm supposed to solve it for y now. Square both sides, that's x squared equals 10 minus 3y. Subtract 10, so it's going to give me x squared minus 10 equals negative 3y. Divide both sides by negative 3. And my inverse is going to be f inverse of x equals that. And I'm going to get rid of this over here to make it look more fancy. Maybe I have to limit the domain on this. The domain would be x has to be greater than or equal to. I don't know. I think I'm allowed to get. No, I think I have to limit the domain. I think I have to limit the domain on 51. So I take the guts. 10 minus 3x has to be greater than or equal to 0. So 10 is greater than or equal to 3x. That's going to give me 10 thirds. Is greater than or equal to x. So for this particular problem, in order for the inverse to work, x has to be less than or equal to 10 thirds. For the original function. For the inverse function, the range would be less than or equal to 10 thirds, but the domain, I'd have to find the range of this. The range of this would be from 0. Y is greater than or equal to 0. So when you find the domain for the inverse, it's going to be the range. So I'm going to say this domain has to be y is greater than or equal to 0. Or if you did interval notation, you would do 0 to infinity, like that. Little tricky, because the inverse is not a function when you square both sides. X squared is not a one-to-one function. 52. Well, this one looks kind of challenging. I'm just going to flip-flop the x and y if I let that equal y. So that's x equals 4y minus 1 over 2y plus 3. Multiplies both sides by the bottom, so that's going to give me 2xy plus 3x equals 4y minus 1. And I could go one of two ways. I'm going to bring the 4y over and the 3x over there to give me a new equation of 2xy minus 4y equals negative 1 minus 3x. You can factor out the y. And then I would divide both sides by the 2x minus 4. And there's my f inverse. This one you don't have to limit the domain. 53, I believe that's e to the x cubed, e to the x cubed. So I'm going to rewrite it as x, because this is supposed to be y, equals e to the y cubed. I'm going to solve it for the variables, solve it for the exponent, so I'm going to ln both sides. So I'm going to ln this left side, that means I have to ln the right side. When I ln e, it cancels out and just brings down the y cubed. So the new equation is going to be ln of x equals y cubed. I cube root both sides. So y is going to equal the cube root of ln x, or f inverse of x equals the cube root of ln x. It looked kind of difficult when we first looked at it, but it's really not that big of a deal. Flip-flop the x and y, so x equals 2y cubed plus 3, minus 3 from both sides. Divide both sides by 2, whoops. And then after I do that, I will cube root both sides. So my f inverse of x is going to equal the cube root of x minus 3 over 2. No limits on the domain for any of these except for number 51. Number 55, they want me to find a parallel line, and a perpendicular line. So the deal is the parallel line is going to be the same as this. So I'm just going to write down 4x minus 2y equals, and now I've got to figure out what goes over here. So it goes through this point, so when x equals 2, that's going to be 4 times 2 minus 2, and when x equals 1, that's going to give me the value over there for the parallel line. So that's 8 minus 2, which is 6. I can simplify this a little bit. I'm going to divide everything by 2. That would give me 2x minus y equals 3. And that's standard form. So the perpendicular line, the slope of this is negative a over b for the parallel line. So the perpendicular slope, if I find this slope, it's going to be negative 4 over negative 2, which equals positive 2 over 1. So the perpendicular slope is going to equal negative 1/2. And once I get that, I can either use this method or the point slope formula. I'm going to do point slope formula, so it's going to be y minus 1 equals negative 1/2 times x minus 2. Y minus 1 equals negative 1/2, x plus 1, add 1 both sides, y equals negative 1/2 x plus 2. It doesn't tell us what form to put it in, so if you want to rewrite that in standard form, go ahead. If you want to rewrite that in standard form, feel free. If you want to rewrite that in slope-intercept form, I don't know what they're asking. Here is the parallel line, so it's going to equal that. So it's going to be x plus y equals some digit, and I find that digit out by plugging in the negative 3 and the 2. Negative 3 plus 2 is going to equal negative 1. That's the equation of the parallel line. Part B, oh, by the way, this is part A, and this is part B. The slope of this line is negative 1 over 1, negative a over b. So the slope of that line is negative 1 over 1. The perpendicular slope is positive 1 over 1. And it goes to this point, so it's going to be y minus 2 equals 1 times x plus 3. Add the 2 over, so it's going to be y equals x plus 5. If you want to put it in standard form, it would be x minus y equals negative 5. And this is part B, lowercase b. And it could either be this answer or this answer. So they want me to change this into an inequality, and notice it starts at, if I were to graph it, it starts at -2, but it's an open circle and it goes to 3, and it's a closed circle at 3, and it's all the values in between those. So the inequality would be x is between -2 and 3. Notice this would have a bracket on it, and this would have a parenthesis. X is less than 4, so if I go to a number line just to show you how it looks, there's 4, it's an open circle on the 4, and the x value point, the arrow points to the left, it's all the values to the left, so the interval notation would start at -infinity and end at 4, and it touches neither -infinity or 4, because there's no line underneath of it. Interval notation, I can jump right to it, it's the stuff between 5 and 10, so I'm going to start at 5, include it, because it has a line under it, and I'm going to end at 10, and I'm going to exclude it, because it does not have a line under it. Graph the absolute value function, and then use the transformation of this graph to do 1/2 x plus 1 plus 3. I'm going to graph it on a piece of graph paper to make it a little easier to see. The original absolute value function is y equals absolute value of x, so it's going to go up 1 over 1, up 1 over 1, and be a v. That's the absolute value of x. That's what it asked me to graph first. Now it wants me to graph this. It has a vertex at -1, 3, and the slope is 1/2 from that vertex. So I go to -1, 3, -1, 1, 2, 3, and my slope is 1/2. So from there I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, and I'm going to graph that absolute value function now. And notice it's a little wider than the parent function. This one's f of x, and this one's g of x. Change it from the form it's in to the other form, the exponential form. So the base is 49, so it's going to be 49. And the little story is if the 1/2 was over here, you could kick that log leg, can kick that 49 over and push up the 1/2, so it would be 49 to the 1/2 equals what's left over, just 7. If I had it over here, it makes the story go a little bit quicker. The log leg kicks that 4, and the 4 goes over and pushes up that 3, so it's going to be 4 to the 3rd equals x, that number or value right there inside. This one, changing into logarithmic form, log base 6 of 216 should equal the exponent 3. Log base b of 625 equals 4. Without using a calculator, well, I have to know that 64 is equal to 4 to the 3rd. So this is going to give me log base 4 of 4 cubed. And these here will cancel each other out. And the log brings the 3 out front. So they don't cancel out, they actually equal 1. So with the 3 out front, this would just equal 3. Log base 5 of 1 over 25, well, that's 1 over 5 squared. Or log base 5 of 5 to the -2. That -2 goes out front, and this changes to 1, so my answer is -2. And these are doable on the calculator, just ask you to do it without the calculator. This one, if you were to graph a logarithm, the domain is x is greater than 0. So this is not in the domain, so this one is not possible. Because -9 isn't in the domain. This one's just calculator keying. First, in order to do it, that's e to the x, so I'm going to ln both sides. So it's going to give me -x equals ln5. I'm allowed to take the ln of that, and I divide both sides, so it's going to be -ln5 when I divide both sides by -1, and you just type that into your calculator. This one, I'm going to raise it to the e power to get rid of this, so I'm going to base e it, and you're allowed to do that. So for part b, it's going to be e to the ln. They simplify and eliminate one another, so it's going to give me 5 minus 2x equals e to the -3, and then I'm going to minus 5 from both sides, so it's going to give me -2x equals e to the -3 minus 5. And I divide both sides by -2. So x equals e to the -3 minus 5 over -2. And this you can type into the calculator and get a decimal equivalent. That's the exact answer for letter B. Letter C, solving the ln problem. I'm going to take this over to another page. Just bring it down here. This is base E, this is base E, so I'm going to combine these. I'm going to multiply x times x minus 1, so it's going to be ln of x squared minus x equals 1. And then I'm going to base E these, so that's going to give me x squared minus x equals E. So then x squared minus x minus E equals 0. Now I can't factor that, so this is going to be quadratic formula, so I'm going to take this to a new page and implement the quadratic formula. B is -1, A is 1, and C is -E. So this is going to give me 1 plus or minus the square root of 1 plus 4E all over 2. And that's a calculator key in, or you can just leave it like that. That's the exact answer, but I think they want the decimal equivalent. You just type that in the calculator. Log base 4 of 20. Again, just a calculator problem. I'm going to turn it on, and I think if I hit alpha window, it gives me all the goodies. Alpha window gives you the most used items on the calculator. So log base is the one I'm going for. And notice how it has log base. So the log base is 4. And I'm going to right arrow and type in 20. And it's going to give me a decimal. 2.1609. Approximately. I can type that one in also. You're going to hit alpha y equals to get the fraction. And I'm going to do 1 plus square root 1 plus 4. And there is an E button on here. All over 2. And that'll generate a decimal, 2.228. Now, if I want to get the negative in there, instead of retyping it, I'm just going to back arrow up and then go back and edit that and change that to a negative, a minus, I believe. It'll give me a different number. Oh, sorry. I deleted radical by accident. I need to delete the positive sign. There it is. So negative 1.228, and the other one's 2.228. This one up here was not right. Those are my 2 answers for the one prior. 7, a bacteria problem. It doubles every 3 hours. So doubling time is 3. Initially starts off with 100. So for part A, what's the size of the population after 15 hours? So it's going to start off with 100. So the formula is going to be 100 times 2 because it's doubling. That's the common ratio. To the 15 divided by 3, because there are every 3 hours is a half time, is a doubling time. So that's going to be 100 times 2 to the 5th. I can basically do this in my head. 2 to the 5th is 32, so that's going to be 3,200. 3,200 bacteria after 15 hours. Part B, what is the size of the population after T hours? So it wants just a general formula. It's going to be 100 times 2 to the T over 3. That's what I believe it wants. So after T hours, if I plug in whatever T is, it'll give me that. Estimate the size after 20 hours. I cannot do this one in my head. Part C, that's going to be 100 times 2 to the 20 over 3. And we'll go to the calculator on this one. 100 times 2 to the 20 over 3. It'll do it. 100 times 2 to the, I'm going to hit alpha y equals to give me a fraction, and do my 20 over 3. And that's how many there are after 20 hours. 10,159. D, graph the population function and estimate the time for population to reach 50,000. So they want to know when it equals 50,000. So part D, if I graph y equals 100 times 2 to T over 3, that graph is going to have a go through or starting point at 100. And it's going to grow rapidly from there. And he wants to know when it hits, when y equals 50,000. So they want to find this x value on the graph, or time. I'm just going to go ahead and do it algebraically instead of estimate. I'm going to find out exactly where it is. So 50,000 divided by 100 is 500, equals 2 to the T over 3. And this isn't, so once I get it narrowed down to 500 equals T to the 2 to the T over 3, I can ln both sides. That would give me ln 500 equals T over 3 ln 2. I'm solving it for T, so I'm going to multiply both sides by 3. So it'll be 3 ln 500. I could bring that up to the exponent, but I don't have to, equals T ln 2. So I'm going to divide both sides by ln 2. And that'll tell me exactly how long it takes for this to equal 50,000. And it's a calculator key in. So I'm going to go to the calculator. I'm going to hit alpha y equals. Alpha y equals gives me the fraction. I'm going to type in the 3 ln 500. Down arrow over ln 2. Be sure to close the parentheses on these. And that'll tell me how long it'll take to reach 50,000. About 26.9 years. So T equals approximately 26.9 years. So this will be 29 at 50,000. Or I'm sorry, 26 or 27.